Welcome to this explainer. Today, we're going to explore the human body by looking at it as an absolutely incredible piece of structural engineering. Honestly, think of it kind of like a state-of-the-art high-rise building. But we aren't just lingering in the lobby or looking at the foundation. Nope, we are taking the elevator straight up to the most vital, heavily armored penthouse suite of your biological architecture. We're going to examine the physical spaces that literally keep you alive, focusing really specifically on the thoracic cavity and how it fits into that much larger, super dynamic front compartment of your body that we call the ventral cavity. So I want you to take a second and just think about your own internal geography. Where exactly do your heart and lungs live? Now, you might point right to your chest, but how are these incredibly sensitive, constantly moving biological engines safely housed in there? I mean, your lungs are inflating and deflating all day, your heart is just relentlessly beating. How on earth does your body protect these vital organs while giving them the room to radically change shape without, tearing themselves apart? Well, the answer lies entirely in the brilliant design of our internal body cavities.
Okay, let's dive into this. Here is our map for today's anatomical tour. Number 1, the front of the body. 2, inside the ventral cavity. 3, welcome to the thorax. 4, neighborhoods of the chest. 5, built for moving parts. And finally, number 6, why the thorax matters.
Section 1, the front of the body, setting our anatomical compass. Right, so before we walk through the front door of human anatomy, we really need to set our compass. Ventral, or anterior, is a directional term, and it simply describes the front or the direction toward the front of the human body. To put that into a relatable perspective, your toes are anterior to your foot, and your kneecap is located on the anterior side of your leg. So whenever we talk about the ventral cavity, we are talking about that vast, cavernous internal space positioned at the very front of your body. Now, to truly appreciate the front, we kind of have to quickly compare it to the back. The body basically has two main compartments. You've got the dorsal cavity on the back, or the posterior side, which is heavily encased in bone. That includes the cranial cavity for your brain and the spinal cavity for your spinal cord. It is built for absolute, rigid protection. But look at the ventral cavity on the front. This is a much larger anterior space. And unlike that rigid back vault, the ventral cavity is uniquely engineered to house vital internal organs that actually need to significantly change their size and shape as they do their jobs.
Section 2, inside the ventral cavity. The two main suites.
So, this massive ventral cavity isn't just one giant empty room. It's practically a duplex, and it's divided into two really distinct levels. The superior or upper compartment is the thoracic cavity. This is our main focus for today. It's fully enclosed by the rib cage and acts as the home for your heart and lungs. Directly below that is the inferior or lower compartment, the abdominopelvic cavity. And fun fact, this is actually the largest cavity in your entire body, housing your stomach, liver, intestines, reproductive organs, and the whole shebang. But you might be wondering, what separates the upstairs from the downstairs? Well, that would be the diaphragm. Your diaphragm is this really cool dome-shaped respiratory muscle that acts as the literal floor of the thoracic cavity, firmly separating it from the abdominal pelvic cavity right below it. It is the physical border keeping our penthouse suite totally distinct from the rest of the building, while also, playing an absolutely massive role in your ability to breathe. Section 3. Welcome to the thorax, the penthouse vault. Let's move in and see how this builds, because now we are officially stepping into that superior division. And the number 12 is absolutely crucial here. You see, the thoracic cavity is heavily armored. It is bound laterally by 12 pairs of long, curved bones, your ribs. These attach to the thoracic vertebrae in the back, and they curve all the way around toward the front of the body to form a highly protective rib cage. Plus, costal cartilages connect the anterior ends of most of those ribs directly to your sternum or your breastbone, creating this incredibly formidable cage around a highly sensitive space. And what exactly is so important that it needs a cage made of 24 bones? Just look at the vital tenets living inside this vault. You've got your lungs, constantly taking in oxygen, your heart relentlessly pumping, the trachea or windpipe delivering that air, the esophagus transporting your food, and major blood vessels acting as the biological highways of your body. All of these sit safely tucked away within the thoracic cavity. Section 4. Neighborhoods of the chest, subdivisions of the thorax.
Just like any large penthouse suite, the thorax definitely doesn't have a single open floor plan. It has specific, subdivided rooms to keep all those vital organs perfectly organized. The thoracic cavity itself is actually subdivided into smaller, highly specialized cavities. Over on the left and right, we have the pleural cavities, each housing one of your lungs. Right in the center, we have a wedge-shaped portion called the mediastinum. The mediastinum is kind of a bustling neighborhood containing the trachea, esophagus, and those major blood vessels. And nested safely inside that mediastinum is the pericardial cavity, the highly secure, specific room where your heart resides.
Section 5. Built for moving parts. The engineering solution.
So think about it for a second. Your heart is beating, and your lungs are expanding and scraping up against your ribs literally thousands of times a day. How does your body prevent immense burning friction from all that movement? The answer is a brilliant structural feature called the serous membrane. Your body essentially lines these cavities with double-layered fluid-filled bags. You have an outer layer called the parietal layer, and that lines the rigid walls of the body cavity itself. Then there's the visceral layer, which physically wraps and covers the organs, the viscera. Between those two layers is a very thin, super slippery fluid-filled space. Imagine an underinflated balloon. If you were to push your fist right into it, the balloon wraps around your fist, forming two layers, right? The inner layer touches your fist, the outer layer faces out, and the space between them is filled with air or water. That is exactly how serous membranes work in your body. Now, inside the thorax, these membranes actually go by specific names. The double membrane surrounding the lungs is called the pleura. The fluid-filled pleural cavity, it creates drastically reduces friction between the lungs and the body wall during breathing. Meanwhile, the heart is surrounded by the pericardium. This creates the pericardial cavity, offering not just protection, but critical lubrication so your heart can beat smoothly without rubbing raw against all the surrounding tissues. It's an elegant solution.
Now, what's really interesting here is this core truth. The ventral cavity allows for significant changes in the size and shape of the organs as they perform their functions. This is the ultimate design purpose of the entire ventral space, and specifically the thoracic cavity. Because of the ribcage's rigid structure, combined with the incredibly slick, frictionless environment created by those serous membranes, your internal organs can wildly change shape. They can expand, contract, and pump all day long without distorting other tissues or messing up nearby organ activity.
Section 6. Why the thorax matters. The marvel of internal design. All right, let's pull all these amazing anatomical concepts together. The thoracic cavity, nestled securely within that larger front ventral cavity, is nothing short of a frictionless biological vault. We started out by mapping the front of the body. We located the upper suite above the diaphragm. We counted the ribs that act as the cage, and we marveled at those fluid-filled membranes that lubricate everything. The entire setup is flawlessly designed to keep you alive, breath by breath, heartbeat by heartbeat, inside a perfectly orchestrated environment. So, as we wrap up this explainer, I really want to leave you with a thought. The next time you take a big, deep breath, or you feel your pulse pounding in your chest after a run, ask yourself, how is this frictionless movement possible inside me right now? It is all thanks to the incredible anatomical architecture of your thoracic cavity. Keep marveling at the genius of your own body, and I really hope this structured look at the source material has given you a whole new appreciation for the space right inside your chest.